What's it called? On Canvas? I accidentally created a lab in the wrong course, and I wonder if this, because I deleted it, and I wonder if that's, I deleted it, but I wonder if, oh, this one right here, right? Yes, okay. So I deleted it from the module, but I guess it keeps it there. So let me delete it from here too. That was for the other class. You know, I just uploaded it, and then I was like, oh, that's the wrong class. So I deleted it from the module, but I guess it didn't delete it. That's deleted now. Yep. Still getting used to Canvas. All right. Okay, so this is the final review. We're just going to go through this really quick. Oh, bear with me for 2 seconds. I was actually going to have the file in my hand as I went through this. I had it printed out already. I just didn't get it. Okay, so similar in format. It's 50 multiple choice questions. You bring your own Scanton form. It will be, we're going to offer it twice here and once on the coast. So 1 p.m. And then 1:30 on Thursday. 1 p.m. on Tuesday, 1 p.m. on Thursday. Okay, so as you study, pay particular attention to these items. And so we're going to, the final exam is not comprehensive other than the fact that some of the concepts sort of build on each other. We talked about some of the things today in data and accuracy that we also talked about before when we were talking about additional data sources. All right, so starting after the first test, we talked about tables and databases. Databases and tables. So there's a few questions, a few basic questions on how tables are organized. Okay? What do rows represent? Columns, what do the columns represent? The rows are the entities or the items that represent things in space. So there are points, lines, and polygons. It could be counties, it could be fire hydrants, but they're the entities themselves. Okay? The columns represent attributes of those entities. So if you remember that, you'll get at least a couple questions right. So what's a key? A key is a special type of attribute that has a unique identifier that can be used to tie it to another table. The purpose of a key is mostly to be able to do what type of operation. It's also on that. What type of operation do we use a key for? Table operation. When we combine two tables into a bigger table that has all of the attributes of both of the tables, what do we call that? A table join, right. Table join. Did you know what a table join is? Keys are used to do joins on. The key has to be, for one table, it should be totally unique. In other words, it should be a unique identifier in one of the two tables. What is SQL? SQL stands for structured query language, and I don't even think that's on the test. But SQL is the language that we use to ask the table questions. So it's called query language. Another word for query is the questions. Make this a little bit bigger. There we go. All right, so the basic formula to be able to do that. So on the test, what is on the test is you need to be able to evaluate some SQL statements. Not the whole part of the SQL statement, but what we call the where clause. When you go to do select by attributes, you're creating a query statement. So when you create a query statement that says something like population greater than 100, you're asking the table to select all those records where the population is greater than 100. So if I ask you on the test, I say, this is the statement, population greater than 100. You'll need to be able to select which rows will be selected. Okay? I'm going to be a little bit more complicated than that, but not much. It's probably going to have an and or an or statement in it. So I'll say population is greater than 100 and population density is less than 1,000. Area, maybe area. Area is less than 1,000. So you have to make sure both, when it's and, they have to both be meet the criteria in order to be selected. If it's or, only one of them has to meet the criteria. Just make sure basically you need to make sure you know how and or work, and you need to know how to pick out the ones that are greater than or less than. You'll be able to answer the questions, those questions on the test. Right? Now you don't have to actually do any basic table operations, but here you should know the definitions. What is a table join? We already covered that. When you combine two tables based on a common field. Sort. That's when you take a table and you sort it by some value. That one's pretty easy. Query. A query is what we just described here. Calculation and assignment. Calculation and assignment is when you create a new field and you put values into that field based on the values in other fields. That's that one. Those are the basic table operations. You need to know each of those. Right. So you create a new field. You don't have to create a new field. I guess you can calculate into an existing field. Create a new field, and you use the values in another field to calculate a new value for that field. It's actually the mechanism that's most often used for reclassification. Calculation and assignment is the table operation that you implement to do reclassification. So when you do the reclassification that we just described a few minutes ago in getting the fields for, in getting the private land, that one that we described, that's calculation and assignment is what was done, and then you exported it as a second step. All right, functional dependency. Now there were a few slides on this, and it kind of got complicated. But what you really need to know for the test is what a functional dependency is, which means that you have a field in your table that is dependent on another field. The values are dependent on another field in your table. So you know one value based on another value. Basically, you have two values you have two attributes that mean the same thing, but they're both in your data set. It's a functional dependency. What it probably means is that you've joined a table at some point and kept it joined, it became permanent somehow. The functional dependencies should be removed. You don't need to know all the different normal forms, the first normal form, the second normal form. You do need to know what a functional dependency is, and that is that one of the columns is dependent on another column. Typically, you want those removed, and that's what normalizing does. What is this? This is just like a thing to plug in a phone. Okay, let me see if I got all the questions on tables covered. I think I did. Okay. Next one here. The next thing we talked about was basic spatial analysis. And part of basic spatial analysis is to cover overlay operations, particularly in vector. Right? So we talked about the types of spatial relationships that we often test for. One of those was adjacency. What's adjacency? Adjacency is the property of being next to something else. So GIS has lots of different ways for testing next to because that's ambiguous. What is next to? Do you share a common border? Are you within a certain distance of? Or do you only just share even a common vertex? Adjacency can be tested for in GIS, but you usually have to give it a little bit more information because adjacency is dependent on the algorithm or the method that you use. Containment. Containment is a little less ambiguous. Like containment means it's something inside of something else. You may be testing, is it touch or is it completely within or is it completely outside of a particular object? So GIS software is capable of answering all those questions. But it boils down to adjacency and containment, and you should know what those two terms mean. Spatial operations. We talked about lots of different spatial operations, but you should know in general that a spatial operation is a tool, RGIS calls it a tool, where you give it one or more spatial data sets, it does an operation and returns a new data set. We talked about lots of different types of spatial operations like overlay and buffers. Talked about what buffers are. And I spelled reclassification wrong here, but reclassification is another tool.
You said it gives you another data set?
Yeah. So the way most GIS systems operate is they don't modify your data in place. So if you do an intersect, you give it two data sets, it does an intersect and creates a new data set. It doesn't modify your original data. That's what I mean by that. So the results are a new data set. If you do a buffer, it doesn't take your roads and turn them into polygons. It takes your roads, creates a new layer that it buffered out the roads, the distance from the roads. In overlay operations, you need to know how these overlay operations perform, how they work. So there'll be an example on the test where you'll have two layers and it'll ask you to do an intersect. And you'll need to know that the intersect is only those areas that overlap will be in the output. Okay? Or it'll be a union and you'll need to know that the output will contain all the polygons, not just the ones that overlap. Also, you'll need to know how it affects the attribute table. So it's almost always the same, it's just there's going to be more or less records. So in a union, you'll have all the records from every polygon, and you'll have some empty or missing data, because when you union, let's say I union a city's boundaries and a county boundaries. Anytime the city exists outside of the county or the county exists outside of the city, you're not going to get the attributes from the other data set. That's what would happen in a union. In an intersect, you're only going to get those areas where the cities and the counties intersect. There's not any questions that explicitly talk about other overlay operations like erase. Okay. Union and intersect are the only ones that are mentioned on the test. It's really, like I said before, those are the basic ones. You could get anything. In fact, union is the only one you really need. All the other ones you could get from multiple steps. All right. Now that we did that section, let me make sure that I covered it well enough. Okay, so another question that's on the test that has to do with overlay is that if I intersect polygons with points or polygons with lines, what's going to be the result? Well, we talked about that in the lecture, but the result is always going to be the lowest spatial dimension. So if I intersect points with polygons, I'm going to end up with points. It always is going to be the lowest spatial dimension. So that's on the test. Right there. I talked about overlays just being union and intersect, but there are buffers, and then actually the test does mention what a dissolve. Asks about what a dissolve is. Okay? So dissolving is, and I don't have that on there. I'm sorry, but I just looked at the test. So dissolve is where we take a GIS layer and we remove boundaries based on their sharing a common attribute. So that's what a dissolve does. Removes boundaries based on sharing a common attribute. You can, in a dissolve, specify any attribute. So it'll just dissolve all the common boundaries. That is possible. Just don't select any attributes. I'll put that on the test, but just bringing that up. Okay, I think that's good. There will be a question on the test that kind of asks you, it's a very simple scenario that basically says, this is what I want you to do. Which tools would you run to do that? Okay. So kind of like, I mean, I hesitate to say this, kind of like the last lab, but way less complicated. So that it's just 2 or 3 tools that you would run in order to complete the process. And it's a multiple choice test, so there'll be a few different examples of what you would do. I tried to make it so that it's obviously not one of those choices. Okay. All right. So we did introduce this concept back when we talked about basic spatial analysis. It doesn't fit as well into raster, so we solidified it a little bit more down here in raster. We talked about it in vector, but we solidified it a little bit more. We talked about local, neighborhood, zonal, and global operations. We talked about that down here. I think for this class, we only talked about local, neighborhood, and zonal operations. Local, neighborhood, and zonal. So there is one question on the test that asks, it has an example of an operation and asks you to categorize it into local, neighborhood, or zonal. And really, we didn't talk about zonal a whole lot, so it's not those. So there's a question on the test that asks you to categorize local or neighborhood operations. So the key there to know is if we're just talking about combining individual cells with individual cells, it's a local operation. So if I'm adding two data sets together, or if I'm doing something like today where I reclassified a data set and just said, is the slope greater than 7 or 3? Less than, is the slope less than 3? That's a local operation because I'm only looking at one cell at a time. Going cell by cell, I'm asking a question about that cell, or I'm doing math on that cell. That's a local operation. It's a neighborhood operation if I'm going cell by cell, but I'm asking about the neighbors of that cell. I am saying, what's the average of all the values in the neighborhood? That would make a smoother data set. Or am I calculating slope? Slope is looking at the neighbors in an elevation and finding the slope through that line. You're not going to have to calculate slope. I know we talked about the formula for calculating slope. That was so that you understood how it's calculated. You're not going to have to calculate that, but you do know that slope and aspect are neighborhood operations. So looking at the neighbors in order to calculate the value for slope. That's important. That's on the test. All right. Okay. All right, so that's that. Raster overlay. One of the things to talk about on the test is this raster overlay is a little bit more complicated. It's usually just performed by doing some sort of mathematical operation. Okay? If it's, if we're trying to create a suitability map, sometimes it's just adding layers together. Is this layer suitable? Is this layer suitable? Sometimes it's multiplying because we've just got suitable, not suitable. So raster overlay is oftentimes just a local raster operation. And we're basically adding raster layers together or multiplying them together. The time where it gets a little bit more complicated is what if we want to take two different categorical data sets, like one represents cities and one represents land cover, and want to add them together. Well, oftentimes we have to add, if one ranges from 0 to 10, another ranges from 0 to 10, if we multiply 1 by 100 first, and then add them together, we won't get any ambiguous results in our data. We have some slides on that. You should go review them. There's a test question about that. All right, this next question here, kernels and neighborhood windows. You should understand what a kernel does. Kernels are those little, usually 3x3 windows. That's the only thing that's going to be on the test. And what it does is, what you do is you multiply all the values that correspond with the kernel and then add them all up. So, yes, that correspond with the values in the kernel. I'm going to bring it up here. This one's harder to explain by just refresh everybody's memory. I don't see it there. Let me just bring it up in Canvas here real quick. Messed up and hit it twice. Okay. That's the wrong course. Yep. Okay. Here's one where we first started talking about kernels. Oh, that's another kernel right there. This is another one. Okay. So one way to express a neighborhood function is by using its kernel. The kernel is like a moving window. And what you do is you take every value in the kernel and you multiply it by its corresponding value on the raster. So 13 times 1 9, 12 times 1 9, 11 times 1 9, 12 times 1 9, 12 times 1 9, 10 times 1 9, 10 times 1 9, 11 times 1 9, 9 times 1 9. Then, after you've multiplied all those together, you add them all up. And that value is what you store in the output data set there. Okay? So this kernel does calculates the average value. Okay? Here's another example of a kernel down here. What do these kernels do? Well, these ones are really simple because most of them are just 0. You multiply 0 times the value in the data set, 0, 0. The only two values that you're actually multiplying is one that's positive 1 and one that's negative 1. So in reality, what you're doing is you're taking the cell to the west and you're subtracting the cell to the east. Because if you take 1 times the cell to the west, you're getting that cell to the west. And you're taking 1 times, negative 1 times the cell to the east, you're getting the opposite of the value to the east. So you're subtracting this cell from that cell and you're storing it in the center cell. So the result is that you get a linear feature here. If the features are running north to south, you get those highlighted. Here, if it's the other direction, you get linear features running east to west. You get linear feature running this way. It's just a simple kernel. I think that's pretty much all we have. Here's a special kernel for actually accentuating spikes and pits. It's called a high-pass filter for accentuating spikes and pits. But those are, a kernel is simply a neighborhood operation expressed as the numbers you're multiplying each value in the window by, rather than just being labeled. And really, all neighborhood operations can be boiled down into their respective kernels. But just expressing them like that. So the important thing here is that a neighborhood window, one of the important things here is a neighborhood window goes cell by cell, but looks at the neighborhood and then calculates a value, it's usually based on a kernel, and it stores that value not in the original data set. It's just like the vector. It stores it in a brand new data set. It doesn't really matter which way the kernel or the neighborhood window is moving. It's just going cell by cell and storing it in the output data set. Almost all GIS operations work like that. They create a new data set, and they fill up that new data set by calculating some value on the old data set. So if I was in the new data set, create the new data set first. And new data sets, unless you've made an exception, is exactly the same size as the old data set. So I go to the first row and column of my data, and then I ask the old data set, what's the average value of all your neighbors? And I store that there. I go to the next one and do that. That's what a neighborhood operation does.
It stores it in a raster.
Yes, stores the output in a raster. All right, and then terrain was actually, we actually put that all in the same lecture. I still did it over 2 weeks, but it was an extension. It really is a special type of raster analysis, terrain analysis. Okay, you do not have to calculate slope or aspect, but you need to know what slope and aspect are. So that's what that means. What they are should be common. not how to calculate. You don't need to calculate them for this test. Okay. Slope and aspect. Slope is how the elevation's changing, how much the elevation's changing. So looking at all the neighbors and determining how much it's changing in that particular cell. Aspect is what direction is that change occurring in? The direction of change. All right, what's a hillshade? A hillshade is an operation that models the amount of sun that a particular raster data set's going to get based on its orientation. That's a hillshade. Now, hillshades can be analytical, and they can be cartographic. Analytical means that they're actually trying to model the position of the sun. Cartographic means that they are doing it for display purposes. Digital elevation model, what it stands for, what it is. And we talked about that again today, actually. Basic steps to water flow modeling. Here, we had a slide on this. You just need to know the basic steps here and what the basic steps are. So starting with fill sinks, we take a digital elevation model, we fill the sinks first, okay? Then we calculate flow direction. Flow direction is simply the direction of the greatest drop. So the greatest drop is going to be the flow direction. Where's it going to flow to? It's going to flow in the greatest drop. So for every cell, which neighbor represents the greatest drop? There is a question on the test about that. Flow accumulation. Flow accumulation is the number of cells that flow into a particular cell. And then after flow accumulation, we could do something like reclassify to get just the streams. And then optionally, we could calculate a watershed. But we need a pour point to do that. So calculating a watershed requires a pour point. Pour point is the location that is going to be used to define the watershed. So you should know what a watershed is. Okay. Cartographic modeling. So this is really, although I talked about it up here, this is really what I'm counting down here. So I wouldn't even really call it a diagram on the test. It's really just 3 questions. I mean, 3, you're basically going to calculate, you're not going to do them. But there's going to be a scenario where you have to do 3 operations strung together. So that's what I mean by a simple process diagram. So you need to be able to think about that in your head. To be able to solve a very simple scenario. Something like, okay, something like I have 2 layers, and I'm going to tell you something about the attributes in those layers. What are the processes that you need to run in order to get a particular answer? So that's the type of question. There are 2 questions I like that. One requires using a buffer. One requires just doing a couple overlay operations. So you should understand buffering and those other overlay operations that we talked about before. So cartographic modeling is basically this process of stringing together GIS operations to answer a question. That's what cartographic modeling is. And then suitability modeling is a specific type of cartographic modeling. It's basically what we're doing in the last lab, finding a suitable location for something. In our case, it was a lab. In our lab, it was parks. So one of the questions on the test is taken directly from a slide where it asks, the important considerations when doing cartographic modeling. So you should look back at that slide. All right, for this last one, I think I actually mentioned most of the test questions as I was walking through the lecture, but I'll go over it here again really quickly. Oh, I just noticed a question up here. Maybe I'll modify this. Yeah, so these other words are used sometimes. So topology, we did talk about that earlier during the first half of the class. It's just the property of objects being connected to each other. Okay? Topology and connectivity have very similar meanings, and they exist outside of GIS. So the interesting thing about GIS is it's spatial, and the connections have to do with being next to each other. But in mathematical terms, topology and connectivity are related and don't necessarily have to have anything to do with space. Okay? Because we might be trying to model like Facebook connections or something, some other, or just internet connections. But we didn't talk about that in this class. But we do talk about how GIS systems are capable of modeling these type of relationships when they're spatial. Just thought I'd mention that. Sorry. Okay, getting back to today, I talked about most of these. We talked about the four main types of standards. So you should know about each of those. The media standards, the data format standards, the documentation standards, and the spatial data accuracy standards. You should know what each of those types are, what they mean. You should know the difference between accuracy and precision. Just kind of go through those slides where we talked about that three-way interchange, so you understand accuracy versus precision. And then finally, you don't need to calculate RMSE, but you will need to know what it is, what units are in. And as I mentioned, there is a question that looks at percent accuracy, calculating percent accuracy from a contingency table. So there is some math to do in that regard. And that's it, I think, for the test review. Unless anybody has any questions. No, are you talking about for what I was referring to here? Yeah. No, so for that question, basically I give you a thing, and then they're really simple problems to solve. So I actually describe one way I could solve the problem, another way I could solve the problem, another way I could solve the problem, another way I could solve the problem. And there are things inside of each way that are totally wrong except for one. So I say I could buffer this layer and then overlay it with this layer. So that's those types of questions. However, the actual overlay question. So I have a question where I actually have some polygons drawn out, and some points or lines or whatever I choose, and I say, okay, let's say I did a union on this data set. How many polygons would be in the output layer? Let's say I did an intersect. How many features would there be in the output layer? Could I figure out, I have X attribute here. I actually have the attributes on the table. Gotta figure out how much area is within that polygon. Not asking you to actually figure that out, but would it be possible after I did the intersect? Maybe that's a true false question or something. All right, any other questions? Yeah, that example would be true. I'm not sure if that's the exact question. Yeah, so you do need to know how the tables get combined. Trying to find that one. Yeah. I don't know specifically. Okay, yeah, all right, here. How many people? Right. Yeah, so the answer to the question is almost exactly what you said. All right. Any other questions? I'm going to go ahead and stop this, and then